Okay, now we're going to continue with the second part of the lecture. So, when we talk about quality, we have to think about how we can add value to the producer, which are the developers and also the stakeholders or the user of the system. Okay, the software organization gains added value because high quality software requires less maintenance effort, fewer bug fixes, and reduced customer support. Okay, so in the end, it will produce greater software product revenue, better profitability when an application support a business process, or improved availability of information that is crucial for the business. So this adding value perspective must also be a focus for your project, because when you develop, you have to think about how your project can be adding value to your stakeholders. Okay. For example, if you just want to develop the system for the sake of automation, let's say now the client or the user is using it in a manual way, then you want to automate the process, then there is only automation process. But what can they get as a benefit, or what are the added values for the solution that you have? So this will be the selling point of your system. Okay, so in the industry, there are many software quality models. Okay, for this course, you will only be introduced to one model. So we have selected McCall's model as the quality model for you to learn for this course. So it's a very, the McCall model is a very old model. And of course, it has some extension to it, but we will cover the classical version of the McCall's model. So it has these three types of quality factors. The first one is on product operation. This one, product operation, including correctness, reliability, usability, integrity, and efficiency. And for product revision factors, it includes maintainability, flexibility, and testability. And finally, for product transition, we have portability, reusability, and interoperability. So in the end of this lecture, you should be able to at least briefly know what are the definition for each of these and an example of each of these quality factors. And if you are given an example or a statement, you should be able to classify which one it belongs to. Okay, this is a figure to show all the McCall's quality factors, okay, based on the product operation, product transition, and product revision. First, we're going to look at product operation. So the first one is correctness. Okay, what is the definition of correctness? The extent to which a program satisfies its specification and fulfills the objectives. It deals with requirements that directly affect the daily operation of the software. For example, it can be defined in a list of software systems required output. So when we look at the requirement, it will say in terms of the expected output. Okay, here are two examples. Okay, such as a query display of a customer's balance in the sales accounting information system. So we know that an expected output will be a display of the customer's balance. The second example is the air supply as a function of temperature specified by the firmware of an industrial control unit. Okay, that means you have to provide the air supply based on the temperature. So some of the dimensions, remember the definition that we talk about when we see the term software quality. It must be measurable, right? So while providing the quality factors, we have to make sure that each characteristics, in this case is correctness, it has to be something that can be measured. Okay. For example, there are many ways to measure certain attributes of software quality, so we just have to select the one that is relevant to our system. Okay. Example here, the required accuracy of those output that can be affected by inaccurate data or inaccurate calculation. Okay, for example, you can accept 0.005 error rate, for example. The completeness of the output information, which can be adversely affected by incomplete data, or in terms of the up-to-dateness of the information or availability of the information. Say information must be correct, 99%, for example. The standards that are used to document the software system. Okay. The second one is reliability. The definition is that the extent to which a program can be expected to perform its intended function with required precision. Okay, so it deals with failures to provide service. Okay, so the common way of documenting reliability quality factor is to represent that into the failures to provide service. Okay, instead of be able to provide the service, but this is the opposite way. Example, the failure frequency of a heart monitoring unit that will operate in a hospital is required to be less than 1 in 20 years. That means that this is a very difficult requirement to achieve, because you want it to be functioning all the time, and you can only accept it if it is failure maybe once. Okay, that means it's very high requirement, high expectation from the system. Okay, or you can say 10 minutes per month during bank's office hours. So for example, this is for online banking system. They only allow the system to fail to provide service for 10 minutes per month. So the next one is efficiency. So it's amount of computing resources and code required to perform its function. So computing resources can be computer processing capability, can be data storage capability, can be in terms of data communication, okay, can be in terms of time between recharging certain hardwares. Okay, so it deals with the hardware resources needed to perform all the functions of the software system in conformance to all other requirements. Okay, so the next one is integrity. So this is related to any unauthorized access to the software. So it deals with security. Okay, example, is there any requirements to prevent access to unauthorized person, or in terms of data confidentiality, or in terms of privacy? So these are all related to integrity. The next one is usability. So usability is the effort required to learn, operate, prepare, input and output of the program. So it deals with the scope of staff, resources needed to train new employee and to operate the new system. So it is wrong to say that the system should be easy to use, because easy to use is not measurable. So how can you make it measurable? So example, you can state it in a way that can be measured. A staff member should be able to handle at least 60 services calls per day. Okay, that means this is a lot. Okay, and that means it's easy to operate. Okay, or you can say training a new employee will take no more than 2 days. That means it's not that complicated. Okay, or you can say training is not required. For example, when you use iTalim, you were not being trained, right? So that means you want to say that it's easy to learn, and even if you are new user. Okay, so we finish with this product operation criteria or category. But what I want you to observe is that every time we see a quality factor, you should see the definition, see the examples, and see what are the measurable characteristics or attributes that are mentioned together in each of the quality factors. Okay, next we move on to the product revision, where we have maintainability, flexibility, and testability. So product revision is now about, you have already completed the development process. Now you want to maintain the system. Okay, revision means you want to make another version, or you want to update, okay, for further improvement and so on. So it deals with requirements that affect the complete range of software maintenance activities, including corrective and maintenance, or adaptive maintenance, or perfective maintenance. So corrective maintenance means you have an error, or you have errors that you need to fix. Adaptive maintenance means that maybe there is no error, but you want to change it to improve, or to add for current software for additional circumstances without changing the software. And the third one is you want to improve the existing system, where maybe you have requests for change and so on. So the first one is maintainability. Maintainability determines the efforts that will be needed by users and maintenance personnel to identify the reasons for the software failures. Okay, then to correct the failures and to verify the success of the correction. So this one refers to the modular structure of the software, the internal program documentation, programmer's manual. So these are some of the measurable characteristics that can be used for maintainability. Example, the size of a software module will not exceed 30 statements. Okay, what does that mean? How does it relate to maintainability? Okay, because when we say it refers to the modular structure of the software, so the size is not exceeding 30 statements. That means the size is very small. Okay, why is it good? Because it's easier to do changes or maintenance. The second one is the programming will hold the company coding standards and guidelines. Okay, in terms of documentation, why is it good? Because when you follow certain coding standards and guidelines, that means your coding is easier to be understood or to be changed.